Cool. All right, so hey everyone. First of all, big thank you for making it out to our webinar. I'm super excited to talk to you guys about live design. And so my name is Jose Lizardo. I'm a tech specialist with Autodesk. I work for the Media and Entertainment Group. And as the name implies, we're going to talk about live design. So I'm going to assume that no one on this call or this webinar knows what live design is. You've probably heard about it conceptually, but I'm going to run on that premise. Essentially explain to you guys what the live design story is all about. The way to think about live design is really as an umbrella, right? So it's an ecosystem of products and services that facilitates real-time visualization workflows. So whether you're trying to create immersive experiences, immersive walkthroughs, interactive walkthroughs, configurators, virtual reality, augmented reality, these are all workflows and concepts that fall under the live design umbrella. And everything that I'm going to show you in the next hour or so is basically workflows geared towards real-time visualization. So if you haven't heard, we now have a game engine at Autodesk called Stingray. And the bulk of these workflows revolve around Stingray and 3ds Max. So without further ado, I'm going to jump right in and show you guys this quick little video. I like to play this back for two reasons. For one, I mean, it looks really great, right? This is not a render. This is not a V-Ray render or a mental ray render. This is not software rendering. This is actually fully real-time and interactive visuals produced out of Stingray. So they look really, really good. You can create some really high quality, stunning looking visuals out of Stingray, the game engine. And it's also fully interactive, right? I'm actually walking around this place now. I'm exploring it. I'm changing things as we see here with the floor all on the fly, and I get a good sense of what these different materials or these different elements in my design are going to look like way before anything has been built. And that's really what the power of real-time visualization offers. It's a whole new dimension in visualization. Understanding designs way early on, and getting a way better perspective than you can from just a simple static image or a pre-rendered sequence, if you will. All right, so enough about the video. Let's jump into my agenda real quick. So I broke this down into 5 different components that we're going to take a look at today. First of all, we're going to talk about the live design ecosystem. What are these products and how are they all connected, or these products and services, and how do they connect to one another? And then we're going to talk about Autodesk Live. So not to be confused with live design, right? Live design is the umbrella or the ecosystem. Live is its own separate product or its own separate entity that fits into the ecosystem, the live design ecosystem. So we're going to take a look at that and how it connects in. We're also going to step outside of the immediate live design ecosystem and see what other kinds of data, whether we're talking about simulation data or city data, and how can we bring all that into a real-time environment to create these immersive experiences. Then we're going to shift gears a little bit and look at how to design things procedurally inside of 3ds Max using the Max creation graph, and how those assets can be pushed into Stingray, the game engine. And then lastly, we'll take a quick stint into virtual reality and see what the workflows there are involved and what is possible to be, what can be achieved with Stingray and virtual reality. So back to the ecosystem. This is essentially a snapshot of what the current ecosystem looks like, and this evolves very fast because we are constantly developing, constantly increasing the capacities within the ecosystem. But this is the current snapshot today. And now don't try to absorb this all in one shot. I'm going to break it down into smaller pieces. But the first part of the ecosystem, of course, revolves around Revit to Max to Stingray. So Revit to Max is something that we know very well. Many of you on this call, as a matter of fact, especially if you're in the architectural visualization space, you've been doing this for a long time. We have really solid ways of bringing Revit content into Max, whether you're doing RVTs or FBX files. You can file link, you can import. Once at Max, you can create photorealistic stills, animations, walkthroughs, fly-throughs, you name it. What we introduce now is Stingray, the game engine. So you could take that Revit content that you brought into Max, or any other content for that matter, and very elegantly and easily push that content into Stingray using the workflows that I'm going to show you here today. Now, the great thing too is Stingray content can also be pushed back into Max, updated, and with the click of a button, be sent back into Stingray. All right, so this is essentially the technology that makes this happen. So on the left-hand side, we have shader effects. Shader effects is essentially the materials that are inside of Stingray. It's how you create a Stingray material. In Stingray, you only have one material type. It's a shader effects or a Stingray material. The great thing is that these shader effects materials are also found inside of Max. So what that means is when you create your assets to get pushed into the, that are going to go into Stingray, of course, if you use shader effects materials, then you don't have to recreate those materials inside of Stingray. When you push your assets in, they come in one-to-one. It's a node-based editor, and the graph that you create inside of Max is represented one-to-one inside of Stingray. Also, we have live linking. So live linking is the ability to connect Max to Stingray. And so when you want to send content over, it's the simple push of a button. When you want to make changes, it's also the simple push of a button. And lastly, we have camera tracking. So this allows us to connect Max's camera to Stingray's camera. So when I move around Max in orbit and pan and zoom, I see the exact same thing inside of Stingray. And vice versa. I can move Stingray's camera around and get the exact same viewing point inside of Max. And these are the workflows that I'm going to show you guys here today. So back to the ecosystem, what we also introduced recently is something called Creative Market. You've probably heard about this by now. It's been about 2 years since we acquired this website, but this website's been around for about 10 years. It's essentially an online marketplace, and it was very popular and still is very popular in the 2D space, so with illustrators and graphic artists and those kinds of people. Since we acquired it about 2 years ago, we started to build out a 3D asset library. And I'll show you guys a quick little video of what this looks like. This is the landing page for Creative Market. You see we have a 3D category in here. When we click on that, we see all the 3D content available on the online marketplace. This is all very high quality, vetted content. We have a team at Autodesk that is responsible for just overseeing these individual assets that people post. You can set up shop yourself and sell things if you want to as well. The really great thing and why it's part of the ecosystem is that in Max 2017 we actually have the Creative Market store inside the product. So you can log in, browse, purchase, and download all without ever leaving Max and have those assets inside of your scenes literally in seconds. So in this case here, we're taking a look at this dining room set. You see that I've purchased it, I've downloaded it, I bring it into my scene, and now I'm ready to use this in any one of my visualization projects, either in Max or in Stingray. So back to the ecosystem. So what do you produce out of Stingray, right? In traditional visualization workflows, you produce, stills or sequences or animated sequences. In Stingray, you don't produce any of that. You produce basically runtimes or games or executables, self-contained packages that you can send to anybody, and that person can experience exactly what you've designed inside of Stingray. Currently, these are the platforms that we can compile for. There's also PS4 and Xbox One that are also available. I don't put them on the slide because they're a little bit more gamer-centric. But for the purposes of design and visualization, we can compile for Windows machines, of course. We can compile for VR. We currently support the Oculus and the HTC Vive. We can compile for Android devices, iOS devices, and as of very recently, WebGL. And what this means, this is actually kind of cool, and I have an example that I'll show you guys a little bit later. But basically, you can create, as an example, a product configurator, and you can host that product configurator runtime on your company's website as a HTML file. And that can become essentially your the way your customers can experience your products and configure your products on your website. All right, so I'm going to show you guys a quick little demo of a apartment scene that we've been working on. This is a data set that started in Revit, was brought into Max, and was pushed over into Stingray to create this experience that you're about to see. Let's just give it a second or two to load up. There we go. We can hit the start button. And now you see that I'm a person that I'm walking around. I can collide with objects. I can go through objects. And I can experience the entire apartment as if I was inside the apartment. So this is just a really great way to experience your designs, way before they were built. We have a bunch of interaction points in here. So when I approach, for example, this living room area here, notice that the light turns blue. This tells me that I can interact with it. If I right-click, I get to turn on and off certain lights. For example, my ceiling lights. I can turn them on and off. My lamp, I can turn it on and off, see how it affects. Once I'm happy, I can hit OK. So I can analyze things like lighting even inside the game engine. Here I have a box of donuts that is making me a little bit hungry, so I'm just going to open that up and reveal some nice pink donuts. We also have, let's go ahead and just keep going in here. This room here is kind of cool. So you see that the walls turned blue, a little highlight blue there. This means I can change something. So if I right-click, I can change the wall color. Let's go for yellow, see what that looks like. Not so much. Gray, a lot better. Hit OK, my walls turn gray. So I can analyze and understand things in a way that was never before possible with just static images. Here I have a chair that I can swivel, That's kind of cute. Let's go out into another room and see what's going on in these other parts of the apartment. I have this laptop that I can turn on to reveal whatever I wanted to reveal. In my case, Stingray, the Stingray title. I have some other things in here, like this TV. I can turn it on and off. When I approach it, see it turns blue. Boom! I reveal what's on TV. I can turn it off. I have these doors here that when I approach them, I can open them, and then I can close them. All right, so pretty cool stuff. And the last trigger is my favorite that I want to show you is the floors. So I can change the flooring just by looking at it. It turns blue. And then I have this hardwood floor that I can select from. And then boom, I can see what the hardwood floor is going to look like throughout my apartment. And you see that the quality of the shaders and the quality of the look is really, really nice. All right, so this is one example of a runtime, one example of an executable Stingray project that you can create. Now let me show you the workflows that make this all happen. So before I do that, I want to give you guys a quick little tour of the Stingray UI. I'm assuming that for the most part, no one's ever really seen this. This is kind of brand new stuff. So here, of course, we have our viewport. Here we have our level flow. So this guy here is actually quite important. This is a node-based scripting editor. Basically, this is where you program the logic of your experience or the behaviors or how things interact with one another. All those triggers you saw a little bit earlier, the donut box opening, the lights turning on and off, that is all done via this editor here. So we have a bunch of nodes, you connect them together, and you drive the behavior of your experience. We're going to come back to this, by the way, a little bit later and create our own flow connections. Here we have our Scene Explorer, all the components of my project that are currently inside of my level. This, by the way, this viewport is actually considered to be the level. We have our Create panel where we create certain things like objects, helpers, cameras, lights. We have our Properties editor. So if I select my laptop here, you see that I have all the properties associated with the laptop, the materials that are being assigned, et cetera, et cetera. What we also have is the project browser here. So this is a bunch of folders that have all the assets and components of this current project that's loaded. If I double click on these, I have further folders, subfolders, which contain different kinds of assets that I can use inside of my project here. We also have an asset preview window. For example, if I grab this chair and I say right-click, show in asset browser, it's going to locate it in the asset browser here and show me a little preview window of what that chair actually looks like inside of this asset browser here. Asset preview window. All right, so enough about the Stingray overview UI. Let's take a look at Max and how we can send some content into Stingray. So I got this version of the apartment inside of Max, and what I want to do is bring in a chair and send it over into Stingray. So to do that, I'm going to show you guys a brand new tool in Max called the Asset Library. So under Content, we can launch the 3ds Max Asset Library. This is an external tool that basically allows you to gather and centralize libraries of assets that you may have either on your local drives or on your network drives. So if I want to bring in a folder with assets, I simply drag it into this section here, and then a link to that folder is created in the asset library. If I click on one of these folders, I see the assets that are inside of these folders. I can stretch this out here to get a higher resolution thumbnail and see exactly what it looks like. I have a bunch of rich metadata associated with this asset. I have a link to the actual file on disk if I wanted to get to that. Lots of information inside of this asset browser. Remember that this is just a reference to that folder on disk. So if I delete this folder from here, I'm not deleting anything on disk. I'm just deleting the reference. However, also on the flip side, if I add assets to this folder on Windows, they automatically get pushed and are reflected inside of this folder. It's a really cool tool to gather and centralize assets. So from here, you can bring content into Max very easily. We have different mechanisms for bringing them in. You can merge and import. These are silent merges or silent imports, so no prompts. You can extract them in, you can replace, and you can also object paint. So let's just do a straight merge. Let's put this over to the side a little bit, unstretch this window down, and access my lovely sofa right there. So I'm going to grab this guy in. I was set to merge. I'm going to drag and drop it in. It follows my mouse. Wherever I let go is where it will let go. I can turn on select in place with the Y key to turn on select in place, which essentially snaps to surfaces below my mouse. Notice how it's contouring the actual bed there. So let's go ahead and position that right in the corner because that's what we want. All right, so now that I got this in here and I want to send this into Stingray, what do I do? So very easily, we're going to go to the Stingray menu up here. We're going to say Send Selection. It opens up a browser pointing to the same location that Stingray currently has its project open. So a shortcut to that, we go to Content. In this case here, I'm going to dump this into my demo folder of chair. Let's just call this chair and say enter, and then Stingray prompts you with an import dialog. I don't have any animation, so I'm going to turn this off. I'm going to keep all the default settings of the mesh that I'm bringing in and basically just hit import. From here now, in the project browser of Stingray, I can navigate to that location, so demo chair, and now I have my chair asset. I can preview it here in the asset preview window, just like I did earlier, and I have all the shaders associated with it. I want to bring it into my level, simply just drag that asset inside and zero out the translation X, Y, and Z. This is needed so that it lines up to the same place as it is inside of Max. All right, so now that we got our chair in, I'm going to show you guys a couple of cool little things. Let's go ahead and side by side these two programs here. And now that I've sent this asset into Stingray, what I've essentially created is a live link connection. So if I go to the Stingray menu, notice that Connect is enabled. Now I can do stuff like camera tracking. So if I turn this guy on and start navigating inside of Max, you see that Stingray's viewport is reflecting that exact same viewing point. I can zoom, let's go ahead and just get closer. I can zoom in, zoom out, pan, orbit, all of that. I can still come back into Stingray and do the same thing. So now I'm in Stingray navigating Stingray's UI or Stingray's viewport, and I'm seeing the exact same viewing angle inside of Max. It's so connected that I could even go into camera view and Stingray updates to that new position, and I can select my camera, for example, say select camera, and I can adjust, for example, my field of view. And Stingray will also adjust its field of view to represent the new FOV that I'm adjusting inside of Max. So really, really cool, really powerful stuff there. So let's jump back out of, whoop, I selected the wrong thing. Let's jump back out of camera view. So now that I sent this chair in, let's say I want to make a change to this chair. Let's say I want to change the materials, for example. Let's go ahead and do that. I have a material set up here that's I'm going to apply to my chair. This is basically just applying a tweed material rather than leather and a lighter wood color. So I've made a change to the chair. And this is a material change, but this could be lots of different changes. Object manipulation, sub-object manipulation, you name it. I want to see this change in Stingray very easily. Go to Stingray, say update, give it a second or two to compile those changes, and then boom, we should see that new change being reflected inside of Stingray. So pretty cool stuff. Very easy to iterate your projects using this live link connection. All right, so I'll show you guys another cool little workflow, and that's going to go in this view here. So if I switch over to this view, and I'll just go and switch over to that view. There we go. So we see that I have this this door here. Then that if I scrub my timeline from 0 to 100, it opens, and from 100 to 200, it closes. These are called animation clips. This is how you set up animated objects when you want to send them into a game engine. In Max 2017, we have a utility to facilitate the exporting of these kinds of assets that have animations. It's called the Games Exporter, so I'll show you guys how that works. So from the application button, we go to Export. We have Games Exporter. And in here, basically, I'm going to define what I want to send out. In this case here, we're going to make sure that I have my front door or my sliding door selected. I have a selection set saved, so it's selected. We're going to make sure we're exporting just a selection, and we're going to create our two clips. Let's go ahead and just do that. Door open from frame 0 to 100. Door close from frame 101 to 200. We're going to export one single FBX file that will contain all this information, and we need to give it a path. So what's the quickest way of getting to this path? If I come into Stingray in the project browser, I can right-click and I can say Show and Explore. This is going to open up a Windows Explorer with inside of this location. So I can very easily grab this path, come back into the Games Exporter, paste that path in, give it a name, let's call it Door, and say Export. Export was successful. We can close this out. And now when I come back to that folder, notice that I have a door FBX file. But Stingray hasn't actually put it in its project because Stingray is not aware of this FBX file yet. We have to make it aware. And the way to make it aware is to drag the FBX file into the project browser and just let go. And now we get the import dialog. So of course we want our mesh just like we did before, but this time we want animation. We're going to make sure that skeleton is enabled. This is going to create an automatic skeleton. Don't get hung up on what that means. It doesn't really matter. Stingray handles it for you automatically with the FBX file. But we want to make sure that we're importing the clips that we've defined in the Games Exporter, the open and the close. So I can hit import, And let's go ahead and just maximize this view here. Notice that we get our door asset that I can preview in the asset preview window here. We also have the two clips, the door opening and the door closing. I can even preview those animations right here. So let's go ahead, door open, and then door close. We can preview that guy as well. It's pretty easy to get this stuff inside of Stingray. So what can we do with all this, right? So we have the door, we have the clips, but they're not connected and they're not doing anything, frankly. So we're going to connect this whole thing up and make this work. So what we're going to do is, first of all, grab the door, right, the door asset itself, not the animation clips. We're going to drag it into our scene, and we're going to zero out X, Y, and Z, just like we did with the chair. And we're going to use flow that I showed you a little bit earlier to connect all this together. Everything in flow requires a flow node representation, so a node that represents the asset that you're trying to work with. To get this door into flow, the easiest way is to select it, which it is right now. Go into level flow. Let's go to an empty area over here and say right-click, create a level unit of that door. So this node right here basically represents that door inside of our viewport. And then what we're also going to do, and I have them set up here, let me just get to them. There we go. Is those animation clips, if I want to play them, I need to use these play animation clip nodes that I have already pre-set up inside of my project. I just need to associate them to the actual clips themselves. So let's go ahead and do that. This one is going to be door open. This one's going to be door close. And now we're going to tell these clips what to play on, what unit or what asset to play those clips on. The one that we just brought in. Connect these two units inputs to the unit output, and we're good to go. So now those clips know to play those animations on that door. But we need to give this an event. Everything in Stingray is based on an event. When will this happen? How will this happen? And there's a lot of different events we can do. I'm going to keep things very simple and very straightforward and use something that we call a volume trigger that I just unhid in my scene. This yellow cube essentially is a volume trigger that you can create in the Create panel. And basically we're going to say that when I'm inside this volume, make something happen. When I'm outside of this volume, make something else happen. So just like we did with the door, we're going to bring it into flow, right-click, create a level trigger of it, and we're going to say, hey, when I touch the door, play the door opening. When I untouch, play the door close. Very straightforward, very simple to set up. Hit the play button, and let's test that out.
Jose, it looks like you didn't make your bed again today.
Oh, I know. The cleaning lady forgot to come. Sorry. All right, so let's go ahead and just approach the door and make this happen. I approach the door, it opens up like magic, and then when I walk away from the door, it's going to close. Now this is a super simple interaction, but that illustrates, the power the power of the system. There's so many ways you can create these kinds of triggers. So let's go ahead and close that out, and let's take a look at one final little animation, and then we're going to move on to another section. Went a little too faster. So let's say you have, and let's go into another area of this house. Let's go somewhere over here. Ooh, jumping around. So let's say you have an asset like this guy here. I have this fan, right? And this fan has an animation clip of the fan playing or spinning. Let's say I want to have an animation that is continuously playing when I play my level, and it's always, it's always playing on loop. So the way to do that is, let's go ahead and just drag this asset, first of all, into our project. Let's position it something like on the ceiling where it makes sense. And I have all the same assets that came in with the door, same thing, skeleton, animation clip, all that stuff hasn't changed. I'm going to right-click on the skeleton and say create an animation controller. And we're just going to keep the default name, that's fine. And then from here, from the animation controller editor, if I double-click on that guy, we can make this happen. So what we're going to do is, first of all, just delete this first state that's empty and create a brand new one. Right-click, say create clip state. And we're going to associate this clip state to that ceiling fan. And we are going to basically save this out. And now we have the fan playing. Always on loop. It's always playing. I have another fan in here in a second folder that is already all set up. So let's go ahead and just drag this guy in and push it to the top. But see, they're playing back at roughly the same speed, and that's not what I want. So because I have a secondary asset of this fan, I can go into its animation controller and reduce its speed. Let's go ahead and just grab this clip state, say 0.5. You're not going to go as fast, you're going to go half as fast as the other one. So we're going to go ahead, hit save, close this out, and now he's playing back twice as slow or half as fast. And I can keep doing this to all the different fans or all the animated objects that I have in my scene. So pretty cool way to set up these kinds of animations. And again, this is all just using Max, Stingray, all these workflows that I'm showing you. Very easy stuff to set up. All right, so enough about this. Let's jump back into PowerPoint and keep chugging. The next thing I want to talk to you guys about is Live. So Autodesk Live, again, not to be confused with Live Design. This is its own separate product, and it's a few things. First of all, it's a plugin for Revit. It's a cloud service, and it's a series of apps. And what it allows you to do, basically, is to take your Revit project or your Revit building, push it up to the cloud, leverage cloud compute to do a lot of the heavy lifting for you. So it's going to run a bunch of algorithms to simplify the mesh, simplify the object count, reduce object count, optimize things, convert materials. It's going to do that all in the cloud. It's going to also interpret certain aspects of your project. For example, your Revit family doors will turn into automatically animated doors. Your Revit RPC trees will turn into fully modeled, fully textured, and fully animated trees as well. And this all happens on the cloud, and basically you download a live file that you can then view in the live viewer either for the iPad Pro or on Windows. And as of also very recently, one click to VR, literally one click to VR. There's a VR button. If your HTC Vive or your Oculus is connected, you press the VR button and boom, you're in VR. All right, so I'll show you guys a quick little video of that workflow. So from within Revit, we select a view, and whatever is visible in that view, by the way, is what will get pushed up to the cloud. So you got to make sure you configure that correctly. 0 user input. You give it a path on disk to download the resulting file, and you hit go. It's going to upload it to the cloud. It's going to put it in the queue. It's going to process it, so run all of those algorithms on your file, and then what you download basically is a file that can be viewed in this live viewer that you see here. This is a stripped down version essentially of Stingray. So in here you have access to your sun and sky that comes from Revit. This is a fully immersive experience. You can walk around, explore the entire model, and go anywhere. All of your BIM data came through, by the way. I don't know if you saw that. All of your BIM data was maintained and is accessible inside of the viewer. You can jump to locations inside of this project. You can walk around. You can fly around. There's a lot of different ways you can navigate. It's very smooth and it's very, very elegant. All of your Revit views come through as well as live views. You can reorder them, you can rename them, you can delete them, you can create new views, and once you're satisfied with your views and you go into this presentation mode, you can basically swoop to all these different views. So this is almost like a presentation tool of your Revit project. All right, so this is all great, and this is actually really cool, but where things start to become really magical is when you take that project that came from the live cloud service and you inject it back into Stingray, because what it essentially is a Stingray project. Now, if you think about what's happening here, you're leveraging the live cloud service to do all of the heavy lifting for you, all of that work that would have been required in order to get a Revit model ready for real time. You're leveraging the cloud to do that for you, and you're injecting it back into Stingray. Now you have access to all of Stingray's tool sets, 3ds Max for animation, Creative Market for assets to embellish your projects, and you can really take your projects to the next level in ways that are unimaginable. And you can compile, of course, for any one of these platforms, or you can push it back to the live editor. So I give you guys a quick little demo of what that could possibly look like. So I have here this project. This is basically the project we just saw inside of PowerPoint that was brought into Stingray. See, we have some nice little birds that are flying out into the sky. It was brought into Stingray, it was embellished, it was pimped out, and now it was turned into something that looks a hell of a lot better. We baked all of the lighting, we tweaked all of the shaders, and let's take a quick look at this. So I hit the tap and go. I can walk around and explore freely. I turn around here, I see that I have a nice little water feature that we added inside of Stingray using the shader effects shaders that I mentioned earlier. Our pool looks a lot better. We have some animated people that were brought in from 3ds Max. Let's go ahead and make this a nighttime shot. The night actually looks a lot better, and the reason is because we baked all of the artificial lighting inside of the house. So when we go into night, we still see all that lighting, but we get our nice starlit, moonlit sky. So let's go ahead and just explore this space here. You see that if I approach these doors, they're going to automatically open. That happens on the live cloud service. Let's take a look upstairs and see what's going on. I can go up these stairs. I can fully explore this environment as if I was really in it. And that's really, really freaking cool. We have this bedroom up here, and let's say, this is my funnest feature in this whole thing. Let's say I want to get to the patio outside by the pool. So what I could do now is I can essentially click on this and let go. I wish you could see me because my hands are not touching the mouse or the keyboard. And it automatically takes me there. That's because the live cloud service also creates an automatic nav mesh. So if you want to navigate this way, you can also do that as well. And I did mention that it's one click to VR. So this button right here down below, VR beta with a little head with the headset on, if I had a HTC Vive or an Oculus connected, which I don't right now, and click this button, I would jump directly into VR. All right, so pretty freaking cool. If you haven't given it a try yet, I urge you, try live. All right, so I'm going to jump out of this and keep going with the webinar. All right, so let's take a look at how to extend the ecosystem. So to do that, whoops, wrong folder, I'm going to go ahead and launch up a project that I've been working on with a few colleagues of mine. And this started off as a project for Fox. So Fox wanted to essentially have wind simulation or simulate wind and overlay those graphics, that wind graphic, on top of the broadcast of a football game, the Super Bowl stadium back in 2014. And back then in 2014, they were using a combination of products, both Autodesk and non-Autodesk products, to achieve this workflow. But there was a lot of problems, right? It was not very flexible. The products weren't all connected, and being able to quickly turn around these simulations was a bit of a pain and really, really difficult. So since then, the Max team has been hard at work to facilitate these workflows and to streamline this a little bit more. So we have tools now inside of Max to import and interpret and visualize CFD data really elegantly. And with, of course, Stingray, we can push all this very, very easily into the game engine and create these interactive experiences. So what you see here is just one wind simulation from one wind direction. I'm going to show you guys at the end of this the final version of all this. But let's jump into a PowerPoint and see how this was generated. So the first thing I needed when working on this project was a stadium. Now, many of you probably have access to stadiums, especially if you're working with Revit. I didn't have access to a stadium, so I used a SketchUp importer. I love using SketchUp files because online there are a ton of SketchUp files, both free and paying, and they come into Max very elegantly. And also the other great thing about SketchUp files is that they are georeferenced, right? So when they come into Max, they're correctly aligned and correctly oriented. And for something like creating wind simulations, that becomes a super important detail, right? So if I come into my top view here, you see that when I select my compass that came in with the SketchUp file, I see my north, I see my south, my west, and my east. And if we go into Google and type that stadium in, the Keenan Memorial Stadium in North Carolina, and side by side these two windows, you see that they are aligned exactly the same way inside of Max and inside of Google. Now, I didn't change the model in Max. I didn't turn it around. I didn't rotate it. This is exactly how it came in. So I was in a really good starting point to get going. The next thing I wanted was some contextual surroundings, right? So a stadium is cool, but a stadium floating in space is a little bit boring. So I leveraged a tool called InfoWorks 360. Now, InfoWorks 360 is a very sophisticated civil engineering tool. But just as a tool used to generate real-world GIS-based cities, it's really, really freaking cool. It's as easy as dragging an area on a map, hitting go, it gets processed on the cloud, and what you get in InfoWorks is this very rich, very detailed model of the city surrounding the stadium. And then because this is all FBX files and textures, it's one click away from being brought inside of Max. All right, so I get the stadium, I got the city. The next thing we need to do is simulate. So we have a product at Autodesk called Simulation CFD. And it's pretty straightforward product. I'm not a simulation expert, and I managed to create some wind sims. Basically create a new design study, bring in the model of the stadium. This is a low-res or proxy version of the stadium that we remodeled inside of Max. And it guides you through some of the things that it needs to fix in the model in order to keep going. Here we're creating the wind tunnel. Once the wind tunnel has been generated, now we define some materials like what is air, what is steel, what is gypsum board, what is plastic, those kinds of things. And then lastly, we define some boundary conditions. So where is my air coming in from and where is it exiting the wind tunnel? So once you define all these properties, and you mesh it, you mesh out the project using the auto size, you can essentially just run the simulation, and a few minutes later, your simulation is complete, and you can even visualize it here inside of Simulation CFD with these nice detailed trace lines. Now, each line that you're looking at right now basically represents the wind direction throughout the stadium and also the velocity, or how fast is it traveling through these traces with this color-coded scheme. This now is ready to go into Max. From CFD, you can export out a CSV file, so a comma-separated value file, that you can read and import and read inside of Max. So that's the next or the last step of the process, is to visualize this stuff inside of Max. So inside of 3ds Max, we have a new object node called CFD Import Data. It reads those CSV files from CFD, a lot of acronyms there. Here we're loading in our simulation coming in from the east. And it comes in as this point cloud. This is essentially a velocity field is what they call it. Each point in this point cloud has simulated data, in our case direction and velocity. The next thing we create is a CFD spline path object that allows us to recreate those traces. It needs to read the imported data, which we just assigned it to, and it needs a generating geometry, or geometry which it will use to generate those splines. So every vertex on this organic shape that I have here will generate a spline. It will traverse the stadium and accurately represent where the wind is in those particular parts of the velocity field. It's fully procedural, so as I move that organic shape around or alter its subobject's vertex position, the splines are always continuously updating to accurately reflect where they are inside of the velocity field. All right, so now we got the splines, we got them in. Now we want to give this a visual style. We're going to leverage shader effects, or Stingray shaders, because this is going to go ultimately into Stingray. And we're going to create animated arrows to basically interpret the wind as it's flowing through the stadium. So these are all capabilities that are very easily achieved using the Stingray shader or the shader effects platform inside of Max. Furthermore, what we're going to do is we're also going to visualize the velocity that comes in from that velocity field, or that point cloud, or how fast is this arrow moving. We're going to apply this CFD color vertex modifier to our splines. We're going to link it to the imported data, and we're going to visualize this using vertex colors in the viewport. And this is something that Stingray will also be able to do. So whatever is more red is wind moving faster. Whatever is more blue is wind moving more slowly. All right, so it's pretty straightforward and pretty easy to understand what's going on here. And because this is all just polygons and textures, all of this is ready to go into Stingray with just a couple of clicks. So let me go back to the stadium and show you guys that we have in here quite a lot of simulations. We actually simulated 8 different wind simulations, and they're all visualized with the same sort of visual style. We also have different camera animations, and I'm cycling to these, by the way, by hitting keyboard keys on my keyboard. So I hit the 6 key here, I can switch to a different camera view, and I can alter a different and visualize a different wind simulation. So again, this is all fully interactive inside of Stingray, and the really cool thing is, imagine now if you put a VR headset on and you were standing inside of the field and you were understanding how wind was moving through the field by seeing these arrows fly by you. It's a pretty impressive experience. I actually do have a VR experience of this stadium. All right, so enough about this. Let's keep going. 1:40. I think we're doing good on time. Back into PowerPoint and move on. So just to kind of summarize what we just saw here, right? So we're bringing in SketchUp data into Max. We're bringing in CFD data, simulation data inside of 3ds Max. We're bringing in InfraWorks data to generate that contextual surrounding. We're massaging the whole thing inside of Max, and we're pushing it into Stingray to create those interactive and immersive experiences. Another workflow, completely different workflow here, or a completely different use case, is to create a product configurator experience. So here we have a KitchenAid mixer assembly inside of Inventor. We're going to send this over into Max. Those animations, or those driving animations that were defined inside of Inventor, are maintained now when brought into Max, which was not the case in the past. Select the constraint you want. They come in as baked keyframes on my timeline. So when I scrub my timeline, you see I have that same constraint that I defined inside of Inventor. Now, this is just a few clicks away from creating what you see here, which is basically a product configurator experience. We have all kinds of different triggers for modifying all kinds of different aspects of this particular mixer. And this, now that we support WebGL, can be hosted on a website. It's that easy to do. So pretty cool stuff, and I'm going to move on to another portion of this whole thing, and that's around procedural content. So before I do that, I will need to just launch up a few things. So give me a second here. Let me go ahead and launch up my roller coaster project and do that. And then let's go into Max. I don't want to save. Let's go into, close this guy out, restart the engine. Let's go into Max. Maximize this guy and load up my final project. Oops. Max, and there we go. All right, so Max is going to open up the file. Stingray is going to open up the file. That's all good, and you can go back into PowerPoint. So if you're not familiar with the Max Creation Graph, this is a tool that we introduced back in the 2016 release. It's a node-based scripting editor, and I'll play back this video to show you what this looks like and lower the volume a little bit. So this is essentially a system and a platform that allows you to extend the capabilities of Max. You can create all sorts of procedural tools like geometry, modifiers, shapes, animation controllers, you name it. All right, so this video just kind of showcases very quickly a bunch of different examples of Max Creation Graph tools that users have been creating. The really great thing is if you're not if you don't have scripting background or programming background, you don't have to worry about it because there's a lot of people that are creating tools and are hosting them online for free, so you can leverage someone else's tool. There's a huge Max Creation Graph community already out there since we released about a year and a half ago. All right, so I'm going to show you guys a tool that we created internally let me just zoom out a little bit, that we created internally to promote the Max Creation Graph, and that's a procedural roller coaster generator. So I'm going to go ahead and just pop it into my scene. Again, this is built with the Max Creation Graph. I can just pop it into my scene right here. I'm going to zero it out to X, Y, and Z, super important when using Max Creation Graph tools, and come to the Modify panel. So you see that we have a lot of parameters in here to create this procedural roller coaster. Among other things, it needs a few lines or a few splines. We need the track line, the upline, and the ground. The track line is the path that the roller coaster is, of course, going to follow. The up spline will help us do a banking and swerving and curves and that sort of thing. And then the ground is so that we can create procedural pillars for the roller coaster automatically. So let's go ahead and assign those. We get our track line, assign it to our heart line, get our up line, assign it to our up line, and grab our ground and assign it to our ground. So you see what gets created is this kind of, crappy looking, low res roller coaster track. And the reason for that is because we also have a mode called proxy tracks. And this is actually really, really important because if I disable this, yes, I get the full on roller coaster that you're about to see, all the bells and whistles, all the geometry, all the bolts, all the ladders, like every part of the roller coaster. This is all procedurally generated. If I modify any aspect of this roller coaster, everything updates procedurally. But because this is a super, super dense graph, very complicated graph, it's not super interactive. And in order to fix that, we have this proxy track mode that allows us to make changes to the track very interactively. And then when you're happy, you just disable that. So let's go ahead and make some changes. There's a lot of settings in here to adjust things like rail distance, rail size, ribs, the amount of ribs, rib size, your central room, your pillars, you name it, there's options in here for everything. I'm going to focus on the actual path itself. So let's go ahead and just grab our splines and make modifications to that. So I can grab my my heart line there, and I can move this guy over here. I don't like that path there. Everything follows really nicely. We can also adjust the up direction a little bit. So if I grab this, push it down, whoops, notice that the track is turning and I was trying to face that new location of that vertex. That's what the up spline capability allows for. So let's do something like that. And once I'm satisfied, I can select my racetrack my roller coaster object, and I can turn off proxy track modes. And then boom, we get the new position and all the glory of the roller coaster. So other things you can do on this guy, we can assign materials automatically through this tool. I'm going to click the button and assign shaders. It's going to assign Stingray shaders to the roller coaster automatically. And I'm going to send this guy over into Stingray now. So let's go ahead and just select this guy, say, oops, I selected the wrong thing. Let's select the actual race track itself. Say Stingray, send selection. Again, just like before, it's opened up to the same project that's currently open in Stingray, which is the roller coaster project. Let's go into demo and say coaster. Boom, inside of Stingray, we're going to get a nice little prompt We don't want animation, we just have a coaster, and we're going to say import. So if we go back into Stingray now and navigate to that location, content, models, demo, we have our coaster and all the shaders associated with it. So let's go ahead and just drag this into our scene, just like we did with the chair a little bit earlier, zero it out to X, Y, and Z. And let's go back into Max. What we also have on this racetrack or this roller coaster tool is the ability to create a procedural camera. So I can hit the create button here. It's going to create a camera. I can go into camera view by hitting the C key. I can adjust my Z so I'm facing the track properly. And we can even simulate a camera animation along this path using physics-based simulation. All these settings in here, gravity, minimum, brake at percent, these are all gravity-based settings that take into account momentum, speed up, slow down, all of that. So let's go ahead and just adjust some of this. Let's go set our minimum speed to 30, and when we're happy with our settings, we hit the simulate button. Notice that my timeline adjusts, and now when I hit the playback button, my camera is fully animated, and all this happened because of the max creation graph. All right, so now that we got our camera animation and our camera, let's send this into Stingray. So I'm going to select my camera. Just like anything, we can send anything into Stingray, not just objects. My camera is selected. I'm going to go to Stingray. I'm going to say, actually, I'm going to go the old-fashioned route. I'm going to go Max Application Button, Export, Export Selected, and we need to give this a path, just like we did with Stingray a little bit earlier. We're going to grab this path here, Show and Explore, and a Windows opens. I'm going to grab this path, go back into Max, paste this path into my browser, give this a name. Let's call it Camera. Say export. Really important in here, I'm going to go to animation, bake animation, and I'm going to make sure I'm baking this animation. This will create that animation clip that we did a little bit earlier with the fan and with the doors. Say OK. Just like before, the camera file exists, but Stingray is not aware of it. Again, to make it aware, drag it into Stingray's project browser, and then make sure that we turn on animation, because this time we do have. We're going to import it in, and let's just go ahead and just move out of this view a little bit, and let's go ahead and use our camera. So just like we did with the roller coaster, we're going to drag it into our scene. We're going to zero it out to X, Y, and Z, and we're going to use flow to connect this whole thing up. So I want to do two things with flow. First of all, I want to create an effect that when I start my level, I'm viewing my scene through that camera. But I also want to be able to trigger that animation and move with the camera. So to do that, first thing we're going to do is bring the camera into flow. It's selected in my view. Go into level flow here. I have a few nodes kind of pre-set up to help speed this up a little bit. So what we're going to do is bring that node in. Then we need to extract the camera information from this node here. So we have get unit camera. By the way, to search for nodes, you hit the tab key. And you have a context-sensitive search that you can search for nodes there. So we're going to extract the camera from this unit here. We're going to set active camera. What camera? The camera we extracted. From what unit? The unit we just brought in. So that's all great, and we want to make this happen on level load. We want it so that when I start my level, I'm immediately viewing my scene through this camera. We also want to play the animation, so we have an animation clip node here set up. Let's go ahead and assign that animation clip node to the camera clip that I just brought in, and make sure we're playing it on the unit of the camera itself. So now at this point, we're pretty much ready to hit play and test this whole thing out. Give it a second or two, fingers crossed. This is going to work. I have faith. There we go. Hit the control key. Oh, and we have our lovely unicorn is still there. All right. Not sure what happened there. It was supposed to be gone. But anyways, you get the point. We're riding the roller coaster. And the great thing, too, is this is an actual VR experience, right? So this is actually done for the Oculus. So if I have the Oculus connected, I would actually be riding the roller coaster. And let me tell you, you better be sitting down when you do that. All right, so speaking of VR, let's shift gears one last time and move over into the last segment of my presentation, and that's around virtual reality. So I want to bring it back. I want to bring VR back to Stingray, back to live design, and what does it mean in the world of live design? So if you want to create a VR experience using Stingray and live design, in Stingray we have a concept of templates, which are basically pre-configured projects that are geared towards different use cases. For the case of VR, we have a template called the VR Steam template. This Steam template is specifically for the HTC Vive. We also have the VR one next to it that's for the Oculus. But the VR Steam one is really, really jam-packed with a bunch of functionality that you can use in your projects very, very easily. So if you open up the VR Steam template, you have a learning level that you can navigate and explore. There's a whole bunch of interaction points. For example, we have this baseball bat that you can pick up with the controller. You can knock those baseball bats. Those baseballs, I should say. You have teapots that you can pick up and throw around. You have a valve that you can open and close. There's a whole bunch of different interaction points. And the great thing is that you can look at how these are built and basically reverse engineer these onto your own assets to create your own custom VR experiences. And what we've also added is inside of Flow, we have a whole bunch of new nodes that allow you to access certain components or certain parts of the HTC Vive controller and the HMD, the head-mounted display as well. So really powerful stuff. Creating VR with Stingray is actually really, really easy. I did create my own project myself, and I'm not a VR master. But what I do want to show you as I'm closing off is we had 4 interns at the San Francisco office over the course of the summer come in and study VR, understand what is VR, what does it mean to interact in VR, and create a very compelling VR experience that I want to share with you guys here today. So I'm going to go ahead and play that back.